Welcome to our weekly Friday space where we feature different topics and different speakers talking about different things tech and development. Today, Jon Reid is going to be leading the discussion. And it's going to be centered around his blog about safety nets and guardrails and how to turn your next defect into a win. Some of you may already be familiar with Jon, but if you're not, Jon, can you take a couple of minutes and just kind of introduce yourself, who you are, and kind of how you got to the point that you are now? Jon, you still with us?
Oops, we lost John.
Uh-oh.
Okay, I see him typing something in the Slack channel.
Okay.
Hey, Fazaro has also joined us. Welcome, Fazaro.
Hey, howdy. I am a John, but I'm definitely not. I'm not Jon Reid.
Hilarious. Nope. Okay. Let's give it a minute or so. We do have some new faces in the room. We're having a little bit of technical difficulty. Jon Reid is getting reconnected. We just introduced the space, which today we're talking about how to turn your next defect into a win. And then just waiting on Jon to give us a quick introduction just about his background and kind of how he got to the topic that we're discussing today. Hey, Jon.
John, you're kind of breaking up. I think it'll be better if you change the net.
Back?
Yeah, now you're back. Now you're back. Okay, great.
I can't
All
wait to see how you turn this into a win, John.
right. That's perfect. Yeah, so
Wow.
we're fantastic. So I think where we left off was
Am I back? Hopefully I'm
yes, you're
back
back.
now.
Yep, you're
Okay.
back. You sound
I'm going to
fantastic.
stick with
Yep.
Wi-Fi.
Oh, perfect. No
I don't
worries.
know.
So we're just saying,
My cell.
um,
Yeah, stop my
say,
backups. Skips. Stop. Ah. Jay,
say
if you
you're
were
fine.
saying anything, I could not hear you.
Okay, well let's do it
And
again.
I'm back.
So I was
Hopefully
basically
you can hear me.
introducing. You're fine. We can hear you. Can you hear me? Can you hear me, Jon? Maybe, maybe not. Ooh, we might have lost him. Can anyone hear me?
Yeah, we can hear you.
Oh, we can't.
Okay.
We can't hear. No, honestly, I'm just kidding. We can hear you. I think John is having some issues. All right, back.
Wow. I honestly had to leave and come back to turn it off and turn it back on again.
All right. Seems like you're doing good now.
Okay.
So,
We'll cross our
dare
fingers
to be.
and hope we're good. Shall we?
Okay, perfect. Jon, can you hear me?
Yes, thank you.
Okay, fantastic. So, I was introducing today's topic, how to turn your next defect into a win. And I thought a good place to start would be for you, Jon, to kind of give a quick introduction of yourself and a little bit of your background and how you got to, and I guess what drove you to write about this topic.
Well, I've been a professional geek for a while, um, in the geek in the programming sense, and somewhere along the way, I got test infected. Actually, I know exactly where along the way. I was reading about um, design patterns, and I'm like, there's got to be a place to learn more about design patterns. And I found this thing called the C2 Wiki. And lo and behold, there was a whole bunch of good stuff there that turned me on to extreme programming and other great stuff and great people. And I guess most of my professional career has been playing in uh, Apple environment type situations. So lately, that's iOS. And why did I write this? I wrote this because I was working with a client and observed that they were finding and fixing bugs and saying great and dusting off their hands and moving on to the next bug. And I thought, what a waste! What a shame! What a I won't go as far as to say a crime, but in a way it is a crime against themselves. It's a wasted opportunity to learn something new, to learn what you can improve to, like, how did that bug get there? Not who made it, we collectively made it. How did we do that? And how did we get away with that? And of course, how do we stop that from happening is the big question. So that's the quick intro to me.
Fantastic. I think a good place to start would be to define defect. I know that based on different organizations that I've been at, different places will define a defect differently depending on where in the life cycle it pops up. So how do you define defects, particularly in regards to like this conversation?
Oh, I'm sure there are good definitions of this. I'm being pretty hand wavy and saying, well, I guess for the purposes of the discussion, I was specifically thinking of escaped defects. That is, bugs that made it to the customer. They're out in the wild. And what do you do? Well, you fix them, yes, and you fix them quickly, yes. But I learned from an old book, Writing Solid Code. Let's see, how old is that book? I'm not sure I can find it quickly on my bookshelf. But it's a book by Steve McGuire. I think he was a Microsoft person, and the book was notable at the time because at that time, Microsoft had a not good reputation in terms of software quality, but this book came out and it shone a bright light, Writing Solid Code. And the author's two critical questions he asks is, how could I have automatically detected this bug? Not found it incidentally, but how could we have detected it automatically, and how could we have prevented it from happening in the first place? So those are the two main questions I want to ask about anything that gets out, a defect, a bug that escapes and makes it all the way to a customer. Now, I do also want to point out that bugs that make it all the way out, they are in a feedback loop, right? We either have an actual human who will complain to us and say, hey, this thing is broken, or we have reports of some kind. Somehow or another, you discover that a bug has made it out and that information has come back to you. So that is a feedback loop, and that is a valuable feedback loop. What I want to do is tighten the loops. One of the first things I learned about extreme programming is that if you picture a series of concentric loops, and like out at the big planning phase and releasing and so forth, at least back in the old days, we didn't release it that often. And the loops get smaller and smaller and smaller and smaller until finally it's just like you and your buddy coding together, pair programming. And so if a defect has made it all the way out, it's like, okay, how can we bring it in one level of detection or prevention in the loops? And then how can we tighten that further and further?
So when we talk about, okay, and that's great perspective, because when we talk about defects getting out, like when we talk about the process, obviously we have a lot of smart people working on these things, and no one intentionally is trying to let it out, right? Or not necessarily that they're not capable of creating code or creating products without them. So how usually are these things getting that far to the point where no one's catching them? What are some of the typical pitfalls that you see on team?
Typical pitfalls, I think, often fall into the edge case and corner case things. where the programmer has sat down and made it work. And of course, this is where it's really helpful to have good testers, good QA folks. I think there's a misunderstanding lately in the industry. It's like, oh, we're a whole team now. We don't have testers. It's like, well, yeah, but what about their expertise? Did you lose that? Did you forget that they are able to attack really critically problems and say, what happens if I throw this or that at it? So there's that level that's further in. I guess another level that's further out than that is dog fooding, where you are your own customer before you release it out into the wild. And that's pretty popular. I think most companies have adopted that mentality of like, we're gonna use it ourselves and discover problems. But fundamentally, I think a lot of problems come from not writing automated tests and not being test driven. There, I said it.
I love it. And I see a lot of new faces inside of the room. So we're talking to Jon Reid about how to turn your next defect into a win. If there's anyone in the audience that wants to ask a question or add a thought or contribute something, a piece of knowledge that they themselves have experienced, please feel free to raise your hand, and myself or one of the other moderators will bring you up to the stage. This is an open conversation for everyone to contribute and get from. So don't hesitate if you do have something that you would like to add to the conversation. So, Jon, I know that you and other ILers are like very big on test-driven development, very big on automated testing. What's the resistance that you typically experience when you're trying to get teams to move towards that way of development?
The biggest resistance is that people say, I've written my code and now I need to test it because they were told to. And that is fundamentally hard. It is usually painful and no fun to write tests after the fact. And usually those tests, all they do is prove your pre-existing assumptions about the code. Like in a way, a lot of the time they only mirror the code. They only like say, yeah, the code does what it does. And so they're not adding value, and they're hard to write. Oh, I got a weird sound. Am I still on?
Yeah, there's some new people joining us on the speaker panel.
Okay, good.
No worries.
Okay, good. So testing after the fact, just it's just not as valuable, and it's harder, and getting people to understand that testing first, starting with a simple little hypothesis, it's much more along the lines of not quite science, but taking a successful case and growing it so that you're adding more and more capability slowly. And by definition, it's testable because you have to write the test first, which makes you write code that is testable. So flipping that on its head remains a challenge. There, of course, many discussions about why it hasn't caught on, or why we have maybe a new generations of programmers who were never exposed to it, or who experience it poorly. But when a bug gets out, that's usually my first question is, why there's a missing test. If this thing escaped, then what test can I write? Again, now this is definitely after the fact. What test can I write that will fail if I put that bug back? And you don't stop to do that before fixing the bug. You should, of course, fix the bug as soon as possible. But then I like to put it back and say, okay, now, how can I write a test that will pass when the fix is in, but fail when the fix is not in? So that's a basic step that I think is good to apply if you don't already do so.
And that, oh, go ahead, John.
No, that's it.
The other John.
The other
Oh,
John.
other John. Hey,
John
welcome.
J3 at this point.
Yeah, there's 3 Johns. Come on, Fazara, you got to get your name with the John in there. I was just about to say what you said, John. My go-to response is whether it's my own code, and I'm actually just about to throw up my hands on a test that I can't get to pass. But that's another story. Yeah, I always look at it as, well, cool. There's a bug that escaped. Obviously, it's a missing test, and I'll usually say to you, write a failing test first, and then you fix it with a caveat. So I'm just going to twist a little bit on what you said.
Yeah.
I don't let people off the, myself or anybody off the hook. No, you write a failing test and fix it, unless it's one of those things where it's like a 2-second fix and an hour long. And of course, it all depends on the urgency and, is the server down, all that other crap. But in general, it should be a rare event that I fix it first, commit, push to the server, and then write the test. But that does happen sometimes. So that's allowed in the interest of time and urgency and severity of the bug, of course. But yeah, in general, if anything should help people think about TDD, maybe you're new, but hey, how about the first time you get a bug? And I don't know the answer to why it's hard to convince people to write tests and first as opposed to test after. But I often wonder, is it some teams have this artificial, well, maybe it's not artificial, this unfortunate siloing of someone else. My stuff, I got a QA, the QA, and so yeah, there's a whole long conversation, and probably I would say things that might be a little dramatic around that topic, because I think, be a professional, be a craftsman. What doesn't stink if my code works because I wrote tests, and I'm accountable for not only my own code, but I'm accountable to my team. And why that isn't the general feeling of a lot of developers who might not write tests and expect someone else to, they throw their stuff over a wall and expect somebody else to catch it. I don't know. I don't know the answer to that.
Well, I don't tend to think it's the developer's fault for having that attitude. That tends to come with the environment.
Yeah, that's kind of what I was saying, is when you have a siloed place and you're putting it in like that, and you're beating the the devs with the whipping the ponies harder, as Ron Jeffries might. Yeah. I mean, I agree. But
well, and to your earlier point, John Kern, that is actually something that I started doing, was using defects as kind of the foot in the door for automated testing and for test-driven development, rather than, because if you give somebody a broad target like that, like automate all the things, or we have to cover all the code in tests, that's, nobody's going to take you up on that. And if we can introduce the test first idea, even in a test after situation, like having repaired a bug, then it seems to, it sort of shrinks the surface area of the nonsense that TDD appears to be for people who aren't used to it.
Yeah, that's a good. I like the attitude of, it's like a foot in the door. Maybe you'll start to change some minds and open some eyes.
And I'll say it was Jon Reid's blog post that kind of seeded that idea for me this last week.
I also think in terms of like why developers are often not exposed to it of late is that developers these days are working in very complex frameworks, for example, iOS or Android, where the system is calling your code. You know, you generally don't write main and put a bunch of stuff in there. Instead, main fires up this other thing that calls you. And so it's more complicated, which makes it harder for people who haven't seen. Like, it's like, well, I don't know how to test this code, and I don't even know what code to test. Like, I don't even know what there's this idea that I don't know what it is, so how can I test it? Where the solution to that is to spike it, to do a spike solution where you discover, okay, what are the buttons and knobs, the particular framework settings that I need to set in order for this to work. Discover, and that's just plain old hacking. And that's right. And I think that's where everybody starts. And that's as far as they go. But what you can do is you can take that hacking, turn it into knowledge, and say, okay, now I know that I need to set this particular flag on, a view or whatever for this to work. And then you can step back and say, okay, so what's a test that asks for that flag? It's not as great as, like testing full behavior or logic, but I think it's the reality for a lot of, at least front-end developers, is you have lots of knobs. What do you do?
So something that I thought of when John Pizarro and John Kern were talking is something that you mentioned earlier when we first started this space. And John, you said not focusing on who the defect came from, but how, like the process by which this defect got through. And so when John and John were talking about culture of the team and how, and using those opportunities to bring in test-driven development and kind of change the way in which people look at approaching the building. Is that the type of scenario that you were referring to when you were talking about turning a defect into a win?
Oh, yes. Because discovering that you're missing a test is just like one example of a larger question. And in a way, like, I think I've only ever watched one episode of Marie Kondo and her system of cleaning up. But it came to mind because part of what she teaches is that to deal with clutter, to get rid of something that in your house that you no longer need, you pick it up and in proper Japanese style, you thank it. It did something for you. You don't need it anymore, but you thank it and you give it some gratitude. I want to bring that same mentality to bugs and say, thank you. You've revealed a hole. Now, what kind of hole? There was a really good comment on the blog from Pedar Zelenovic, who said that he's now thinking of what kind of technical, procedural, and behavioral guardrails that he's missing. I thought that was really good to break it down and say it's not just code, right? Because it's people making the code. So there's also questions we need to ask about how do we shape our culture. And just for example, having a discussion on your team about, okay, for the next bug that gets out, or the next bug that someone finds, even that hasn't gotten out but is reported. Okay, let's slow down and talk about, as a team, how do we want to approach this culturally, and what are the lessons it's offering to us.
So, what are some other ways we can start to approach? Um, what are some other ways we can utilize defects to start to approach changing culture around how we look at defects and how we look at building and working together as a team?
Wow, that's a big question. Anyone want to jump in on that? Hmm.
Start collaborating and stop just cooperating.
Yes. No blame.
Are you guys saying stop, collaborate, and listen?
What?
What?
Now let me just talk over you. Yeah, well, I think it's again if depending on the culture and the team, yeah, you might get radically different mileage, so to speak. But yeah, I think if the team is willing to sort of look at how they produce value, dare I say, a value stream, and if they have an inkling of interest in lean or being agile, even dare I say, or just pragmatic, and looking at time spent and time in waiting and number of reverse flows going on because of said bug. Uh, there's opportunities, but that's being a professional and that's being a craftsman and that's having the space and the culture to do that. Uh, there's one counterpoint I remember a manager friend of mine saying at one point. Um, you think sort of in defense, he goes, I, I never asked the developers to take shortcuts, or I forget how he put it, but kind of to his point, a lot of times I've fortunately I've got a huge dose of autonomy, and I've long tried to do the right thing and use the motto better to beg forgiveness than ask permission. But I know that's me. So it's easy for me to say that, and it may not be easy for developers and folks to act differently and try something. But hey, you get paid whether you write the test or don't write the test. Probably no one's looking at it that close. Try something new.
You mentioned something about reversal. Basically, if code is going through or features are going through this process, and something has to go back up the chain, right? And in a way, a bug that gets even all the way out is that, and in its worst case scenario. And one thing that I think teams can discuss and say, for better value and better time use, the further out it gets, the more expensive it is.
Absolutely. Yeah, I use a dopey phrase, mind the gap, just like you might see on a subway. And I use that to say, if you can only think of one thing from an agile perspective or being pragmatic, it's the gap in time between taking an action and getting a response. And you're exactly right. A, a bug that gives you a response because you wrote a test in a matter of seconds. Oh, okay, that's pretty cool. One that maybe a QA person catches, a holistic testing, not somebody, whatever, but that's a little longer, could be days or weeks. Which is, I think most people realize that their headspace is gone. Weeks later, they're no longer in wherever they were when they wrote that code. And then the most egregious offense, so to speak, is it went out the door, and you found it way later. So yeah, that's kind of how I think of it. Is that's that gap gets costlier and costlier potentially.
Mm-hmm. Now, I titled this blog post "Safety Nets and Guardrails" because the book Writing Solid Code asks two questions. One is how could we automatically detect this bug? How could we have? But the other is how could it have been sort of prevented in the first place? And while TDD is part of the answer to that, there's another aspect to it that I want to mention, and that is making it harder to be able to write the bug in the first place. Making it, structuring your code so that that type of bug becomes harder. And what I mean by that, a good example of that is that oftentimes inexperienced developers use the primitive types, strings, numbers, collections, and they just use them all over the place. And so that a string, for example, a string is a string is a string, and any parameter that accepts a string could accept the wrong string. Whereas if you say, no, this isn't just any string, this is a part ID, this is a part identifier, and you say, let's create a type for this, whether that's a class or whatever it is. And everywhere where we use a part ID, we use this type instead. That's going to cut down on a class of bugs of, you might say, they're piping issues. You can't plug the wrong plug in if each plug has a different shape. I hope that makes sense. Basically, a string is a string is a string, and anything that accepts a string, you can just plug in. But if it's something different and you can't plug it in, then you can't make that mistake.
A phrase that came to, I don't know if it's quite right, but of course you're talking, getting a little more constrained with types or designed by interface, like your term for a plug. If it's a 3-prong, US style plug, you got to come to me with a plug that's going to fit into this hole, and you can check for that. Yeah, that's an interesting thought. Is you're basically thinking of classifying the types of errors you're seeing, structural or architectural ways to totally get rid of those if they're problematic, forming a pattern. I like your thinking.
And most likely you're missing those objects, those types, where responsibilities can be closer to the data and functions living together. What a thought! I'm still a believer in object-oriented programming. Forgive me, but I think that it still works. So that you're reducing your surface area of, like, if I change this, what does it affect? If we talk about bugs as damage, we're reducing the blast radius of a mistake. It can only go so far before something really catches it. And of course, hopefully we have tests to guard against all that. But that's an example of what I mean by moving from a safety net, which will catch you when you fall, to a guardrail, which prevents you from getting into that situation in the first place. And primitive obsession as one example.
Well, there's a reason that there's a term type safety, because if you're using the type system properly, it's going to give you safety.
I guess so.
I wanted to take a minute just to kind of reset the room and let everyone know who's listening. If you did want to ask a question or submit a thought, feel free to raise your hand with the raise hand icon, and one of the moderators will bring you up. If you can't raise your hand or if you can't speak because you're joining from your laptop or desktop computer, feel free to inbox me or one of the other co-hosts, and we'll ask your question for you if you can't speak. I did want to ask Jon, when you talk about guardrails versus safety nets, I think obviously I would assume that most people would prefer guardrail, right? Like something that'll catch it before you need the safety net. What types of situations are one better than the other?
Oh, I want both. Give me both, because for every guardrail, there, I'm going to miss something. There's going to be a gap. I say I mean we programming collectively. We're going to miss things, and so when that happens, I also want the safety nets. Both and.
Yeah, I would agree.
And coming back to extreme programming and the feedback loops, the tightest loop of all is you and the people you are coding with, collaborating together, working on the same code, having a conversation about, what about this or that? It suddenly strikes me that in a culture of where people are treated as individual contributors and they're expected to deliver solo, all by themselves, and the only sort of check on things is reviewing pull requests, that is missing a huge opportunity for safety and for discovery and for to have somebody else say, okay, great, but how could we stop this from happening? In fact, even the process of writing this blog post, I had input from others, and Tim Ottinger, let's see where it is. He suggested to me and improved my article by giving me feedback and asking, can we not only prevent that bug, but is that bug signaling that it is part of a family of bugs like it? And how can we eliminate that whole family? Oh, that sounds terrible. But how?
Family of bugs.
Yes.
And I know there might be people that like bugs, but
still terrible in a Buddhist sense. Yes.
Or I even learned, I think there's a Jain, Jain.
Yeah, the Jainists.
Yeah.
So how do you relate all this to tech debt?
Tech debt. There are different ways to understand that phrase, and people mean different things when they say it. So one example of, I think, how it fits with debt is that debt itself. Ward came up with technical debt, the term, as a metaphor to try to explain to his the folks in his domain who were finance folks why it was important to clean the code, why he was spending time going back and cleaning all the time. He said it's like debt, that if all we do basically is pay down, maybe don't pay it at all, well, that's bad. But if all you do is pay the bare minimum, then you're still accruing interest. And the problem is, like, it's just going to linger on and on and on. And so I think that's part of one way of seeing technical debt is that when you have a defect and you find a fix for it, to then not to say we are more than justified in taking the time to investigate how to do prevention and detection, and invest in that throughout our system, because that will pay off. Like, that is paying down interest, paying down the debt in a big way. So that's one aspect of technical debt.
All right, thank you for that. And we have a couple of new speakers. Welcome, Todd and Anthony. Todd, would you like to add something here? Todd, are you with us? All right, you're breaking up a little bit. Could you might leave the speaker and try to join again? Because I think your voice is breaking up a little bit.
It sounded like a bug speaking.
Try again, Todd.
Yeah, I'm gonna offer him the mic again. So over to you, Jay.
Awesome. Can you hear me?
Yes, you
Yes.
can.
Oh, no worries. Todd, if you're having trouble with your mic, feel free to DM me your question, and I can add it to the conversation until you get your speaker working. So we're talking about turning defects into a win. How do you get buy-in? So we talked about getting buy-in from the teams, right? And talked about getting buy-in from developers. How do we get buy-in from leadership? How do we get buy-in? And I like that example of naming it tech debt so that people who worked with finances could understand what they were talking about. What are some different ways that you can get leadership or people who are maybe non-technical to understand, hey, we need to shift our development to test driven so we can reduce the amount of defects that we're seeing in our environment?
I think that the big stakeholders at the top, they don't need to know or care about test-driven development. That's not in their wheelhouse. What they want is features getting out there that don't have defects or fast fixes and saving money. And it was let's see, I'm looking for another book. I'm not finding it. Anyway, Graham Lee wrote the first book on iOS test-driven development. And he started with the question, why should you do this? And his answer was, for the money, to save money. Like that's the part that'll get people's interest and attention, and is a good motivation, I think, for business side of things.
I think customer satisfaction is another aspect. At the end of the day, when a bug does go to the production, it ultimately impacts the customer.
Absolutely. Which will end up being about money.
Are there any cases where it wouldn't make sense or where it wouldn't be, where the effort wouldn't justify the value for changing?
For changing what?
Or I should say for adopting test driven development. Are there any situations that you can think of where that wouldn't necessarily be appropriate or it wouldn't be conducive to the environment?
Well, that's where I think it's helpful to see that test-driven development is a mentality more than a technique. And for example, when you're doing front-end stuff like I do, iOS, and you're dealing with how views appear, or you can't write a test to say, is this beautiful, right? That's a human judgment. And so there's in the strict, like, write a test first, a failing test. There's no failing test for beauty. But what you do is you say, I'm creating feedback loops, and I'm observing that the changes as I make them, and tightening that feedback loop from from code to seeing it as fast as I can. And that is where on more modern declarative systems like Jetpack Compose for Android or SwiftUI for iOS, people are excited about those things because they can see, I can make the change and actually see if like that's the right color or if that's the right type of rounding that I want, or shadow, or whatever. I guess shadows are passe. Um, uh, but and they can see it like that. Though that has never slowed me down. Not, or I should say, not having a preview system like that has not slowed me down, because what I do is I write a test. I do write a test, but all it does is capture the view and show it to me. And so just by rerunning the test, I can make the tweak and see in the test result how it renders, how the view looks, without having to go through, especially without having to go through and saying, okay, I'm going to run the app manually. And let's see, I have to get through the login screen and dig into where was it? It was in this thing, and I need to create an order and finally get down to the view that I need. Like, don't do that. That's super. That's a big loop. We want the smaller loops. And instead, I write a failing test that just keeps failing and showing me the results until I say, that looks good. And then I'll say, capture that. That's the view I want. And now the test passes. That's a classic. It's been called golden master testing. It's related to characterization testing, but it is, I think, in its heart, more closer to golden master testing, where you're like, I'm going to tweak until I say, this is good, now let's lock that down. So is that test-driven development? I think it is. Is it exactly the same as what you might read in a book? Not quite. Again, if you adopt TDD as a mindset, it opens up a whole world.
Yeah, I agree completely with that, John. It also shows up if you find yourself coding in an environment that doesn't have like a unit testing framework available. You can still, like, I don't know, write a line of code that prints out your expected result, and you see that it's different. So you almost sort of end up writing your own framework. It's in your mind. It's in the loop of how you work, and you're always looking for that smaller loop. And if you don't have the perfect tool, you make it.
Oh yeah, and us old folks, back in the days before there was unit testing frameworks, we were doing that. We would write, for example, inside of a single source file, we'd create a separate main just for that file to say, I just want to run this, not the whole thing. I just want to check my little main. And then JUnit and all the XUnit stuff came along and made our lives even better.
I am curious, when you talk about kind of old school versus new school development and what's popular and not so much, what do you think has like caused that divide?
Whoa.
Or at least heavily contributed to it.
I get the feeling from tutorials of all kinds, and this runs the spread from just some solo YouTuber like me putting stuff out there, all the way to official documentation from Apple, for example, that shows this is how to write it so that it works, so that you get this piece of functionality to work, but they don't show, and this is how you automatically verify it. So more and more information is getting out there from both individuals and from companies and even from books that don't start with the test first. I think Stephen Baker mentioned to me that Jeff Langer's book on I think it was Effective Java. I don't have
Java. I think it
what
was Agile Java.
Agile Java. That Jeff's book is one of the few, if not maybe one of the only, where instead of starting with "Hello World," it starts with a failing test, and I love that. And I feel like that's a missing piece across our literature, and it doesn't get filled in a lot of times because people now they see it works, great, ship it. It's like but you're not building up your infrastructure of safety nets and guardrails.
Yeah, not too long ago, I found there's a Learn Go with tests, which is same idea. It walks you kind of progressively through the Go language uh, in a TDD fashion. So you're always starting with a failing test, and that's rare. I specifically went out and looked for that.
We need more of that. That sounds great.
Yeah, I think I agree with you, John. I think there's also what I've seen. Oh boy, and maybe since I've started in the industry, is that there's much more of a focus on tools and much less of a focus on practices. And I think that's a deep subject to mine there. I believe it probably has something to do with the fact that software engineers get promoted up and out of software development rather quickly. So there's a lot of focus on tools and just getting the right answer, and not as much of the depth of that we get out of practices and things like design.
If I were teaching elementary school kids programming, I would like to start with a failing test. Say this is our hello world. How do we get it to pass? Look, you change this thing over here, and it by changing it on this side, it affects the light green, red or green on that side. Cool. It's fun.
Yeah, at that point, it's not test-driven development; it's just development.
Yeah. I wasn't expecting this to be like a TDD heavy discussion, but it ended up that way.
Oh, I'm curious, what direction did you think it was going to go in?
I don't know.
I did think there was a lot of potential in like, what the hell is a bug? And because I mean, there's one obvious case, or at least obvious to me, that I see, defect or bug thrown around as a label for a missed requirement. That I wonder if you think this would apply even in that case, even if people were divided. A bug is anything that comes back from a tester as wrong.
Yeah.
That's a good call out.
That always gets me going. Yeah. No, that's not a bug. Just because you couldn't figure out what you wanted.
Oh yeah, of course.
And
I mean, it's definitely
built it
like in my view, it's definitely like, put that on the left of the board. That's a new thing. But
yeah, and
I think just for the sake of the discussion, we should talk about that.
And yeah, because part of what we do as Agile practitioners is try to get value out as soon as possible. And that value doesn't mean it's complete. That value doesn't mean it's all the bells and whistles. Maybe it's just one bell. There is no whistle, but it does ring. And so I think that's helpful to separate bugs from missing features. Say no, that's okay. It's not complete. let's keep adding.
Yeah, that's part of if you're able to step back and be more holistic and think about what you're doing, trying to deliver value. That's a swing and a miss. That's, especially if you got all the way out to the users, that's a big, expensive reverse. Well, I wouldn't even call it a reverse flow, because it's sort of you just went down a dead end street and now you're stuck. Or I don't know the good analogy, but the key there, it comes back to mind the gap. Were too egotistical to think you knew what somebody wanted, or that your process was perfect. What can we do to fix it? Where did we go wrong? We built what you told us, but now you say it wasn't what you wanted.
And that again comes back to something familiar to XPers is the loops. We tighten the loop by not having the customer at the far end of it. Bring them in.
Exactly. Reduce the gap.
Mind the gap. I'm going to remember that, John. That's great.
Yeah, and the other aspect beyond TDD is BDD. It's the outer loop. It's the behavior that you're looking for that can drive tests well. So I use a combination of BDD and TDD.
All right, we are about to come to a close. So I'm looking for closing remarks, and then we can end the session.
What to offer as a closing remark? I guess I would encourage you to have this conversation with your teams, where the team includes the managers, to say, we want to make this better. We want to catch bugs sooner or prevent them sooner. What are the things we can do to do that? And there are typical answers that I want to challenge. And one of those answers is, actually, maybe the dominant answer is, well, you need to pull request and we need 3 reviewers on it, because obviously 1 reviewer wasn't enough. And I would challenge that and say, no, that is going down a road that will slow you down. That there are other ways. Come on over. Come learn the better ways. But start with the conversation, because it is your team ultimately that needs to decide how to change your own culture.
Awesome.
Jon Reid, when people want to get in contact with you or ask more questions about this or other topics, where can they reach you?
On Twitter, I am Q Coding, where the Q stands for quality, and that's the name of my blog, Quality Coding. But also, here I am at Industrial Logic, and working with various teams, depending on what I happen to be doing. You can always ping me, contact me through the IL. Look me up on IL, and there's a contact me button. So that's at industriallogic.com.
Awesome. Thank you so much. Thank you everyone who joined the space and listened, asked questions, contributed thoughts. Always a good time getting together every Friday. We try to join every Friday, 3 p.m. Eastern. So if there's a topic you would like us to discuss, or if you would like to feature something that you're working on or some thoughts that you have, please DM us and let us know, and we'll be sure to add you to the schedule. It's a good Friday. It's nice outside, at least where I am. Everyone stay safe and enjoy the fall, maybe-ish weather.
Thank you. Have a good day.
Thank you, everyone.
See you next week.
Thanks, John. Thank you, everybody.